Hello. So, dogs have the same five senses as humans: smell, hearing, sight, touch, and taste. Starting off with their sense of smell, the most mighty of their senses. A dog's olfactory system is miles more developed than any human being's. A dog can have upwards of 50 million scent receptors, sometimes even as high as 300 million scent receptors, depending on the breed and the individual dog. So, dogs have a larger olfactory bulb, which is a rounded mass of tissue in the brain responsible for olfactory function. Comparing this to other mammals with similar sized brains, the olfactory bulb is much, much bigger. A larger olfactory bulb equals higher processing power. Now, I've done a diagram and you can see right there, attached to the brain is the olfactory bulb, okay? Now, dogs are equipped with an upper pathway at the start of the olfactory bulb that sends 12 to 13% of all air breathed into the olfactory epithelium, a thin layer of tissue responsible for detecting odour. And you can see it's this little piece here that is attached to the olfactory bulb. Whilst also having a smelling organ that is called the vomeronasal organ, located above the mouth in the gum line, used for detecting and deciphering pheromones, which you can see just here highlighted with the crisscross pattern. Dogs are also nostril dominant depending on the stimulus. Left nostril dominant sniffing is used for familiar and non-aversive scents, i.e. food, or their owner or familiar people or dogs, and right nostril dominant sniffing is used for aversive, threatening or arousing scents. This is due to the neural processing pathways in the brain put into the dog's physiology. Right hand side processes novel stimuli, left hand processes familiar stimuli. Lastly, a cold, wet dog nose allows a dog to trap scent particles more effectively, which leads to the conclusion that optimized hydration and health will lead to more efficient olfactory capabilities. Next, we have hearing. A dog's sense of hearing, much like their olfactory capabilities, are still much better than that of humans. A dog can hear noises 4 times farther away than the average human, as well as 4 times as quiet. An average human cannot hear sounds that vibrate at a greater number than 20,000 vibrations per second, 20,000 hertz, whereas a dog can hear sounds up to 50,000 hertz. This is the reason we cannot hear training whistles clearly, but our dogs can, because they usually make a noise above the 20,000 hertz mark. A dog's ears are controlled by up to 18 muscles, compared to a human's meagre 6. Thus, a dog can tilt and rotate their ears to funnel noise straight into the inner ear, as well as, in addition, some dogs are genetically gifted to have large convex ears that can amplify and trap noises more effectively. This and the fact that a dog's ear canal is significantly longer than a human pairs to make their sense of hearing far superior to ours, making it the second best sense that a dog actually has. A dog's sense of sight. It carries both positive and negative traits that all in all, paired with their other senses, give them the capabilities that we know and love. Dogs are red and green colourblind. They have a brighter and less detailed sight compared to us humans. As well as this, their peripheral vision is much wider than ours, as their eyes are positioned more to the side of their head compared to our forward-facing eyes. Now here I have a diagram of a dog's field of vision. You can see that the field is quite large, but there is a very, very small area for overlap. A small overlap area leads to poorer judgment of distance. But they have an improved view in low-lit environments. This is because there is higher numbers of vision rods in their eyes and a structure in the eye called the tapetum lucidum, a reflective surface behind the eye. This could be noticed when a dog looks into light when you're out in a dark place or have a flash photo taken, as their eyes will light up and look a little bit scary. As well as this, they have an increased ability to detect moving objects. This is due to a lack of a fovea in the eye. This decreases the detail that the eye can see, but increases an object's noticeability when moving. These traits make total sense when referring back to early dogs and wild dogs, which are well equipped to be nocturnal hunters of camouflaged prey. These traits put together result in a need to lean on more dominant senses like smell and hearing to pair with the visual stimuli to make sense of their surroundings and be more efficient hunters. A dog's sense of touch, my very, very favourite subject on this homework. It's very different to a human's. As humans, we have many receptors on the skin and in other tissues attached to our nerves, which send pulses through the CNS, up the spinal cord, which then travel to the brain, which then notify us how to react to said stimulus. Interestingly, dogs have far less of these receptors, leading to a more generalized touch sensation. Certain areas of their body are more sensitive to touch, like their sternum, upper chest, pubic area, paws, and muzzle, but they experience a lot less stimulation from touch in general compared to humans. Also, dogs do feel pain. On a very similar scale to humans, it has been studied that the perceived behaviour of not showing pain is a genetic behavioural trait used to maintain composure in survival scenarios and promote their survival. Pain in dogs is much like humans. It's a fluid construct that is different for every individual. Some people and dogs are more resilient to pain, and some are less so. Next, the vestibular system in dogs. This enables them to control and balance their body. It is comprised of 3 semicircular ducts in the ears that contain a special fluid that provides signals to the brain that promote balance. This, along with their flexible spine, rudder-like tail, and well-balanced musculature, provide excellent agility, balance, and movement that truly creates an astonishing hunting capability. And lastly, another amazing feat of a dog's sense of touch is their use of magnetic fields. A dog can sense a magnetic field with their paws, and dogs have been using this to orient their bodies to the environment since they were wolves. An example of this, or how they apply it, is how wolves, huskies, and other sled dogs have been observed by scientists using their paws to avoid weak ice structures as they travel over frozen bodies of water, all to promote their survival through their sense of touch. Sense of taste in dogs. Dogs have fewer taste receptors on average compared to humans. 1,700 in the average dog, 9,000 in the average human. A dog takes a few weeks of life to develop their sense of taste, usually the third of the senses to develop, after touch and smell and before hearing and sight. A dog can taste all the main taste groups just the same as us: bitter, sour, salty, spicy, sweet, and umami. The umami and salty receptors are actually fine-tuned to meats and fats and meat-related chemicals due to their ancestral diet being mainly comprised of meat. And as umami is the savoury receptor and salt is the receptor that promotes healthy electrolyte levels and hydration, these are pivotal to a dog's survival. Dogs also have the taste buds finely attuned to water. This ability is also seen in felines and other carnivores, but not in humans. Special taste buds on the tip of their tongue react to water when they drink, and become very sensitive when thirsty and after meals. This encourages drinking and promotes their survival. Luckily for dogs with their dampened sense of taste, their sense of smell more than makes up for it, as both of these senses actually pair together. If anything, the smell of what the dog is eating impacts the taste more than what the taste is. Funny, isn't it? This combination of senses allows the dog to determine whether food has gone bad and is not fit for consumption. Dogs generally use the rule of thumb that an abundance of salt, spicy, sour, or bitter flavour means that the food has spoiled and may have a high presence of toxins. So, that was the senses. I'd like to hear your feedback, Lynette. Thank you very much for watching.